Welcome to Master Simple Physics. Today's topic is on speed, velocity, acceleration, and we focus on graphical presentations and interpretation. The definitions of speed is the distance traveled per unit time. It is a scalar quantity. Velocity is the rate of change of displacement, and it is a vector quantity. Example, a girl takes 250 seconds to walk from A to B following the circumference of walk path. Find the speed and velocity. Speed is equal to distance from A to B divided by time taken. As we know, distance is a scalar quantity. Hence, the distance from A to B should be equal to 4 pi r divided by 2, because this is semicircle. The time is 250. So after substituting, you should be able to get the speed equal to 2.514 meters per second. Velocity is equal to displacement from A to B divided by time taken. Displacement is a vector quantity, hence it is the straight line from A to B, which is equal to 200 meters. So divided by 250 seconds, velocity will be 0.8 meters per second. Normally, when we ask how fast the girl walked or what is the walking speed of the girl, it's not the walking velocity of the girl because speed is more realistic. Definitions of acceleration is defined as velocity per unit time. The equation is equal to A equal to V divided by T. Below, we present three graphs, velocity versus time. The first graph is a horizontal line where the velocity is equal to 8 meters per second over the time period from 0 to 3 seconds. The velocity is constant throughout the period, hence the acceleration is equal to 0. The second graph is the uptrend straight line where the time equal to 0, velocity equal to 0, and time equal to 3, velocity equal to 10. Hence, from here, we should be able to calculate the acceleration is equal to 10 minus 0 divided by 3. The answer is given as shown. Since the time grows, the velocity is increasing, so we call this is the acceleration. The third graph is a negative gradient straight line. When time is equal to 0, the velocity is equal to 10. When time is equal to 3, the velocity is equal to 2. Based on this, we're using acceleration is equal to final velocity minus initial velocity, hence is equal to 2 minus 10 divided by the time t. You will get the negative answer. Acceleration equal to negative value, it means that it is the deceleration. We try to use the distance versus time graph to determine the speed. On the left graph, when time equal to 0 to 3 seconds, the distance is constant at 8 meters. Hence, the speed equal to 0. On the right hand side of the graph, when time equal to 0, distance equal to 0. When time equal to 3, distance equal to 12. Hence, we can calculate the constant speed equal to 12 minus 0 divided by 3 equal to 4 meters per second. Note that distance is a scalar quantity. When time grows, distance cannot be shortened. Free-falling object without air resistance, find the displacement at time t. Examples, a free-falling object undergoes uniformly gravitational field without air resistance for t equal to 1 second. Calculate the displacement of the object when time equal to 1 second. Since this is a vector question, we have to set a reference point. We assume that upward is negative, downward is positive, hence the acceleration A should be equal to positive g. At the bottom of the right-hand corner, there are some general equations for you to use for these questions. Method 1, we're using the equations as given as t equal to ut plus half of gt squared. Initial velocity u equal to 0 because the object is freely released. As the parameters given, the displacement at time equal to 1 is equal to 5 meters. Second method, we are using graph which determines the displacement. To draw the graph on the velocity versus time graph, we're using this equation v equal to u plus at. Since u equals 0, so v equal to tan t. Based on the equation, we should be able to draw the straight line on the graph. Displacement from time equal to 0 to 1 second is equal to area under graph, which is a triangular area, equal to 5 meters. Last example was a free-falling object. Now we consider object is throwing downwards with an initial velocity equal to 4 meters per second. Determines the displacement when time equal to 8 seconds. Similarly, we need to set the reference point. Upward is negative, downward is positive. Hence, A equal to positive g. Now, u is equal to 4 meters per second. The time equal to 8. Using the equation, we substitute the reference parameters. We get the answer is equal to displacement equal to 352 meters. Second method is using graph. In order to draw a graph using the equation v equal to u plus at means that v equal to 4 plus tan t. To draw the straight line as shown, displacement from time equal to 0 to 8 should be equal to the area under graph. Hence, we get the equations is equal to half of 4 plus 84 times 8. The answer is also equal to 352 meters. When time increase, velocity increase, hence this is the acceleration graph. The acceleration A is equal to the gradient of the straight line. The last two examples was falling objects. Now we consider a ball is throwing outwards. The question is, a ball is thrown outwards with an initial velocity 10 meters per second in an uniformly gravitational field without air resistance. Calculate the maximum height of the ball. For ball throwing outwards, we set the outwards reference as positive, throwing downwards is negative. For the acceleration, A should be equal to negative g. At the maximum height, the velocity is equal to 0. Therefore, using the equation, v squared equal to u squared plus 2as, substitutes the parameters, we should be able to get the maximum height or maximum displacement equal to 5 meters. To use graph to determine the maximum height, we have to use the equation v equal to u plus at. Hence, we plotted the negative gradient straight line. Similarly, the displacement will be equal to the area under the graph is also equal to the initial velocity equal to 4 meters per second. Determines the displacement when time equal to 8 seconds. Similarly, we need to set the reference point. Upward is negative, downward is positive. Hence, A equal to positive g. Now, u is equal to 4 meters per second. The time equal to 8. Using the equation, we substitute the reference parameters. We get the answer is equal to displacement equal to 352 meters. Second method is using graph. In order to draw a graph using the equation v equal to u plus at means that v equal to 4 plus tan t. To draw the straight line as shown, displacement from time equal to 0 to 8 should be equal to the area under graph. Hence, we get the equations is equal to half of 4 plus 84 times 8. The answer is also equal to 352 meters. When time increase, velocity increase, hence this is the acceleration graph. The acceleration A is equal to the gradient of the straight line. The last two examples was falling objects. Now we consider a ball is throwing outwards. The question is, a ball is thrown outwards with an initial velocity 10 meters per second in an uniformly gravitational field without air resistance. Calculate the maximum height of the ball. For ball throwing outwards, we set the outwards reference as positive, throwing downward is negative. For the acceleration, A should be equal to negative g. At the maximum height, the velocity is equal to 0. Therefore, using the equation, v squared equal to u squared plus 2as, substitute maximum displacement equal to 5 meters. To use graph to determine the maximum height, we have to use the equation v equal to u plus at. Hence, we plotted the negative gradient straight line. Similarly, the displacement will be equal to the area under graph is also equal to 5 meters. In this slide, we repeat the examples by throwing the object upwards without air resistance. The only difference in this slide is we make the reference upwards as negative, downward is positive. Therefore, the acceleration equal to positive g instead of negative g. Similarly, using the equation, we will substitute v squared equal to u squared plus 2as to get the maximum displacement equal to minus 5 meters. To draw the graph, we are using v equal to u plus at. Now u is equal to minus 10 because outward is negative, whereas for a is equal to positive 10. Hence, the equation is equal to v equal to minus 10 plus 10t. The straight line as shown. Hence, this straight line is the positive gradient. The maximum height or displacement is equal to area under graph, also equal to minus 5 meters, because the area is below the x-axis. Hopefully, through these two examples, you will be able to appreciate the difference between the reference upwards and reference downwards. It will give you different kinds of drawing on the graph. This is a simple example. A car accelerating uniformly at 2.0 meters square second at initial speed of 20 meters per second. Calculate the speed and the distance traveled by the car at time equal to 10 seconds. What is the speed of the car when it has traveled a distance of 400 meters? Before starting to do the question, it is good to list down the parameters as given. In this question, you use two equations. One, v equal to u plus at. Substitute the parameters and get the equation 1. Then we use the equation 2 as equal to ut plus half of at squared. From this equation, we will be able to find a equal to 20 divided by 5. Then you substitute these values into the equation 1. Then you will be able to get the answer of v equal to 60 meters per second. To use the graphical methods, first you need to draw the graph v versus t, and you have estimates. To use the graphical methods, first you need to draw the graph v versus t, then draw the straight line as shown. U equal to 20, v unknown, and the time is equal to 10. The area under graph 400 is equal to half of u plus v times the height 10. Hence, you will be able to calculate the v equal to 60 meters per second. It is similar to use the equations method. In this example, graphical method is easier and faster to obtain the solution. Now come to the end, we hope that you can interpret acceleration or deceleration on the VT graph. We start on the left graph. The first one, A is equal to 0 because when times grow, velocity is constant. Second graph is a positive gradient straight line. The initial velocity is equal to 0. A is equal to 10 divided by 3. Why we call it acceleration? Because when times increase, velocity increase. On the third graph, it is the negative gradient straight line that with the initial velocity equal to 10 and the velocity is decreasing as time grows. To determine the values of acceleration is equal to final velocity minus initial velocity is 2 minus 10. The time period is 3. Hence, we get A equal to negative 8 divided by 3 meters per second squared. Look at the last graph on the right. The straight line is a negative gradient with the initial velocity is equal to 0. The final velocity is equal to minus 8. So acceleration is equal to minus 8 minus 0 divided by 3. You get a negative value of 8 divided by 3 meter per second squared. Negative values is indicating opposite direction. As we mentioned earlier, velocity is a vector. Hence, negative value doesn't mean it's decreasing. It may be opposite direction. The next point you want to conclude is that the displacement, or we call distance, is equal to area under graph. Hopefully, by now, you will be able to understand how to draw and interpret the graphical presentation. Thank you.